Okay, I think we're going to get started, everyone. Good morning and welcome. For those of you who don't know me, my name is Steph Giles. I am a director with the Long Point Biosphere, but most of you in this room would probably know me from my role with Alice Norfolk. I work for an organization that works with local farmers to restore habitat on marginal farmland. And for those of you who don't know me from Alice, I see some former professors and teachers in the room. So hello to the faculty at Niagara College and McMaster University, and I think there's even some teachers from what used to be Port Dover Composite School here. So I'm humbled to see everyone joining us here today. We're not here to talk about me today, though. I have the great privilege of introducing the second session speakers for today. So first up is Amy Hall. Amy is the manager of ecosystem recovery with Carolinian Canada. She has a Bachelor of Science degree in wildlife biology and conservation from the University of Guelph and is currently completing her Master's of Climate Change at the University of Waterloo. Through her work with Carolinian Canada, Amy aims to increase the availability of native seed for restoration in Southern Ontario through projects like the Southern Ontario Seed Strategy and the Conservation Impact Bond. Today, Amy is going to give a presentation titled The Long Point Conservation Impact Bond, Conservation Finance as a Path to Reconciliation. So welcome, Amy.
Thank you, Steph. We've communicated via email many times, but never met in person, so great to see you. Awesome. Thank you. So I'll get started. So hello, it's great to be here today. As Steph mentioned, my name is Amy Hall. I'm the manager of ecosystem recovery with Carolinian Canada. And today I'll be talking about the Conservation Impact Bond and how conservation finance can be a path to reconciliation. And I'd like to share how the bond came to be, what it has accomplished so far, and where it's headed. So first, I'd like to talk about Carolinian Canada's strategic direction. So in 2018, Carolinian Canada made a shift in their strategic direction to include Indigenous leadership, recognizing that Indigenous folks have a vital and active role in stewarding the land since time immemorial, but have not always been given a seat at the table when making decisions about the land in the Carolinian zone and beyond. So we have made a commitment to go beyond a land acknowledgement and to be accountable in our actions. And Carolinian Canada developed an accountability statement which outlines our commitment. And I won't read it today, but it can be found on our website if you're interested. So as you can see, this strategic plan has placed diversity and financial stability at the roots of the tree, signaling the importance of these values in the foundation of Carolinian Canada. Like the diversity of an ecosystem being a sign of health, the diversity of an organization is also an indication of health. Additionally, financial security is essential in order to support our network and to build sustainable relationships and partnerships. And through this strategic plan, CC set out on a new direction, one that centers diversity and looks for innovative financial solutions. And through this vision, the CIB was designed and eventually co-created with many partners from diverse sectors. So ethical space is essential for co-creation. Creating ethical space means to create an environment where diverse knowledge systems are met with mutual respect and understanding, and relationships are built in reciprocity. And since 2018, we have been on a journey of learning what ethical and safe space is and how we can create it. Acknowledging that there have been barriers and are barriers to BIPOC people showing up and expressing themselves authentically in many spaces. And we aim to create spaces that are open, honest, respectful, and where all perspectives are valued in all of our programs with Carolinian Canada. So two-eyed seeing is an essential component of creating ethical space. And I'll read a quote here. So two-eyed seeing refers to learning to see from one eye with the strengths of Indigenous ways of knowing, and from the other eye with the strengths of Western ways of knowing, and to use both eyes together. So Carolinian Canada aims to integrate two-eyed seeing into all of our programs through inclusion of Indigenous leadership, and most recently through the establishment of the Indigenous Leadership Pillar, which is led by Sam Whiteye. So through cross-sector discussions, we have identified that native plants have a critical role in a solutions-based approach that connects ecology, the economy, and ethics, so bridging Carolinian Canada's past and future trajectories. And native plants contribute to ecological and cultural restoration and provide opportunities to grow a sustainable green economy. And so now I will talk about the Conservation Impact Bond. So I hope to answer the question of what is a Conservation Impact Bond. And then I'd like to tell you about our 2 pilots to date, which include the Desh-Kanzibi Conservation Impact Bond and the Long Point Conservation Impact Bond. So I'll start by examining what many traditional conservation funding models look like. So the funds are typically coming in from government or private or public philanthropy. The funding is then used directly to implement environmental projects. An impact is created, and the funding recipient reports on their success based on the metrics which are outlined in the call for proposals. So these funding avenues can be limited, very competitive, and they're also rooted in colonial structures and not accessible to all groups. And also don't provide autonomy of funds where groups are able to use the funds in the ways that best serve them versus in the ways outlined by the funder. So the CIB model works differently. This model starts with a project facilitator, which is Carolinian Canada in this case, who is actively engaging with investment and philanthropy communities to engage traditional and non-traditional funders in opportunities within the environmental and conservation sector. So investors will provide upfront capital, which supports more habitat actions quicker. And Carolinian Canada then connects with a network to engage habitat partners who hold local expertise and are implementing projects on the ground. So these are the folks with the local knowledge who know what their communities need most. And through implementation of habitat actions, outcome payers are attracted and will pay the principal and return on investment back over an agreed upon period of time. So outcome payers are funders who want a green return on investment rather than a financial return. So historically, outcome payers have included government and philanthropy. And throughout this process, we are partnering with Indigenous communities to ensure that there's a two-eyed seeing approach to conservation, and stewardship in the Carolinian zone. So this slide also highlights the role of evaluation in the research team in tracking collective impact throughout this process. Additionally, these diverse sectors are working together in new ways and together are co-creating each iteration of the bond, from investor to habitat goals to project evaluation metrics. So to reach our collective 2030 goals, we need to accelerate habitat. Currently in the Carolinian zone, we're at about 15% natural areas cover, and we will need to get to about 30 in order to meet those goals. And projections based on our pilot show that the CIB model could potentially protect more biodiversity when scaled than current funding avenues and approaches within the sector. So this is due to the CIB's ability to accelerate actions for healthy landscapes through innovative financial mechanisms. As I mentioned earlier, native plants live at the intersection of economy, ethical space, and ecology. And the CIB has proven so far to be a tool to help grow a green and just economy. So the CIB can increase equitable access to healthy landscapes, boost investment in natural capital, and create sustainable jobs. Demand for environmental sustainability is growing rapidly, and biodiversity is a high-impact solution. So the CIB offers an alternative to greenwashing and provides a connection to local habitat partners. So this sort of corporate agenda for sustainability provides great potential, as many potential funders are uncovered, so outcome payers or potentially investors, and they're looking for environmental returns. And so the CIB creates the potential to attract more funding to the sector, And in the pilot phase, for example, attracted funders that were not initially interested in funding conservation or not initially engaged in this sector. And our hope is to make more funds available to everyone in the sector to support projects all over the place. And I'll just quickly mention as well that the CIB connects to 14 United Nations Sustainable Development Goals as well, so it provides an opportunity for us to collectively work towards those goals. And here we can see the CIB coming to life. So this is through the first pilot or first phase, which was the Deshkan Zibi Conservation Impact Bond. So Deshkan Zibi comes from the Anishinaabe name given to the Thames River, which translates to antler or horned river. So this is the Thames River in London, Ontario. And Deshkan Zibi Conservation Impact Bond provided a proof of concept, essentially, and was documented in a comprehensive report by the Ivey Business School in the fall of 2021. So the Ivey Business School has been a partner in the CIB from the conception of the bond itself. And you can explore the Ivey report and story map on the Carolinian Canada website if you're interested. And this bond was also created with many partners that you can see on the screen here, and was actually eventually awarded a Finance for the Future Climate Leader Award on an international scale as well. So here we look at some of the outcomes from the Deshkan Zibi Conservation Impact Bond. You can see that 169 hectares were improved, with over 1,000 people in 20 communities were connected and exposed to opportunities like jobs and training. You may notice that the evaluation of this project goes beyond ecological metrics and includes connection to the land, knowledge and learning, opportunities created, connecting hearts and minds, and connecting our bodies as well. So Ivey Business School facilitated the development of a two-eyed seeing impact evaluation framework with the leadership team, so bringing together Indigenous and settler values and metrics to ensure that the CIB is reaching ecological and ethical goals. So the two-eyed seeing evaluation framework uses relational accounting to report to our investors and funders about the outcomes of each bond. And in the images here, you can see some of the partners in the Deshkan Zibi bond and their associated projects, and can begin to imagine some of the ecological and socioeconomic benefits. And now we'll look at phase 2, which is the Long Point Conservation Impact Bond. So this bond is the most recent iteration of the CIB, and through the LCIB, this bond was co-created with these partners that you can see on the screen. So Long Point Region Conservation Authority, which restored 3.6 hectares of agricultural lands in the Long Point region. St. William's Conservation Reserve Community Council, who implemented 2 habitat projects, which included a sand barren restoration and a sand savanna seed orchard project, as well as the Long Point Basin Land Trust, which activated its network to secure funds for the Stackhouse Forest Sanctuary, and which is a pristine old-growth Carolinian forest that is now under the care of the Land Trust. So you can see some of the members of the team pictured here, and that photo was actually taken in the Stackhouse Forest Sanctuary. And I think I saw some partners maybe here today as well, so it'd be great to connect. And additionally, we were able to partner with an Indigenous-led project that creates space for Indigenous youth, healing gardens, and supporting land-based learning, economic reconciliation, and Indigenous-led opportunities. And they have asked to remain anonymous. So in each CIB, we aim to support projects that save, steward, seed, and lead. So save being long-term protection, steward, habitat management, seed, recovering ecosystems, and lead being that community piece. And through the LCIB, we're able to achieve this goal and basically get a holistic portfolio of projects where we were able to do all of these things here. So obviously through protecting older growth forest, stewarding seed orchards, restoring agricultural lands, and then empowering future community leaders. So in total, the Habitat Partners are stewarding 62 hectares of land from the Long Point Conservation Impact Bond. So what is next for the LCIB? Each bond develops a unique evaluation framework that evaluates if we set out to achieve basically what we said we would do in the beginning. So this bond will be evaluated based on ecological, sociocultural, and economic metrics, and the impact report will be shared in the future. And lastly, what is next for the CIB as a whole? So as I mentioned, we have launched 2 pilots, Deshkanzibi and Long Point, and we intend to host a 3rd pilot in the Niagara region coming up pretty soon. And then we are expanding to the Carolinian zone-wide CIB to support habitat projects in more communities across the zone. So we have really big dreams of what the CIB could scale to, and we're in the beginning stages of gathering leaders to start to assemble those leadership teams and habitat portfolios that could be supported through the bond. So we're learning and deepening relationships with each new bond, and we're grateful for the vision and the passion and teamwork of all of our partners. So a big thank you to all of the partners who have been active in the bond since the very beginning and through each iteration, and especially to the Long Point CIB team, since today is really about celebrating the work that's been happening in this region. So yeah, I just want to say thanks to them, and thank you all for your time and attention. I'll also mention we have a Southern Ontario Seed Strategy poster in the other room, so you can come visit me there or to chat about the CIB or the sauce later today. So thank you.
And I think we have a few minutes for questions, but if you could come up, the folks in here can hear you from the back, but not the folks online. So if you have a question, please feel free to come up and speak into the mic.
Yeah, I know it's a bit intimidating because there's the financial aspect, so maybe no questions. And just so you know, I'm actually an ecologist. I'm not a financial person, so hopefully that all was, legible.
Thank you, Amy. I actually have one quick question. What are some of the tools you're using to make sure you're kind of avoiding the idea of greenwashing?
Yeah, I think the whole idea of the bond is really impact driven on the ground. And obviously we're, centering native plants in everything that we do. So I think the one thing that really sets the bond apart from other models or initiatives I've seen is that it's really about the initiatives that the communities, want to see happen, and we're looking to connect with communities, learn what projects they want to implement, for ecological and cultural restoration, and then support those projects rather than trying to prescribe something, for the zone or for communities. And so it's all really rooted in getting more native plants on the ground, more habitat on the ground, and connecting people back with the land and with each other. So
great, thank you. And will you be around for the break?
Yeah.
For more questions? Great. So if anyone has any other questions at break, please feel free to approach Amy. Thank you. Okay, so next up, I have the privilege to introduce Sophia Zamaria from the University of Toronto. Sophia is a PhD candidate with the Ecological Modeling Lab, joint with the Departments of Earth Sciences and Physical and Environmental Sciences at U of T. Her research focuses on using watershed modeling to delineate trends in flow regime and nutrient loading in the Long Point region now and under future climate change scenarios. Her research also aims to investigate the linkage between agricultural management and watershed health in the region. So welcome, Sophia.
All right. Hi, everyone. Thanks for having me here again this year. I had a great time presenting some results from my doctoral research last year. So it's a really big privilege to be back here. speaking about my research again. So as Steph said, my name's Sophia. I'm a PhD candidate at the University of Toronto. We're going to take it back to the physical processes of the region just for a quick second. Today I'm going to be talking about how watershed modeling of what we call rain-on-snow events improves our understanding of flooding and phosphorus loading in the Big Creek Watershed. And I know that's a big title and there's a lot to unpack there, so we're going to go really slow, step by step, and then at the end I'll finish off with some updated results from over the last year. So let's start just by figuring out what exactly a rain-on-snow event is. Can I actually get a show of hands? Has anyone ever heard of this before or knows what it is or thinks they know what it is? Okay, so I'm really glad to be able to define it here. So it's actually a really simple process, and I'm sure everyone in this room before has experienced this before. It is quite simply the process of rain falling on an existing snowpack. So these events are really dependent on temperature. The temperatures have to kind of have a sweet spot where it's cold enough that there's still a snowpack on the ground, but warm enough that rain instead of snow is able to fall down on them. And this process is actually, it doesn't happen everywhere in the world, but it's very common, lucky for us here in the Great Lakes Basin. Okay. So why do we care about rain-on-snow events? The main thing that happens when we have these events, and let's see if I can play this video. Yeah, it might not. So this video is supposed to show like a really big rushing stream. What rain-on-snow events do is increase stream flow. So there's a lot of water flowing in our streams in a very short period of time, and it's going really quickly. And this happens through two things. So first of all, when the rain falls directly onto the snowpack, it's not able to permeate into the ground, and so it runs off directly off of the snow and ice into Big Creek. And then second, because we're seeing warmer temperatures, we have an increased melting of the snowpack, and also because the rain is physically dislodging the snow, there's going to be a lot of water melting, both from the rain and from the snow, going right into the river. Okay, so why is this important? I'm sure that you've probably gathered one of the answers, and that is flooding. So just to kind of drive this point home, I'm going to take everyone back about 10 years ago to March 2013. Here we're looking at stream flow of Big Creek just around the Teeterville Reservoir, and this is March 1st to March 15th. And so before I even was looking at rain-on-snow events, when I was looking at the river data that we have available, I saw this huge peak that you can see around, I don't know if you can see it, the dates on the bottom, but it's about March 11th to March 15th. So this big peak in stream flow was very, very large, very out of the ordinary, and it lasted for a long amount of time. And so I thought this had to be some sort of extreme event that was going on. So I actually went back into the news archives to see if anything was recorded about this, and sure enough, it was picked up by the Simcoe Reformer, and this was a really big flooding event that happened in March. And this is one example of a rain-on-snow event. So really hits close to home here. And it's really worth looking into how these rain-on-snow events are currently affecting flooding in the watershed and how they're going to be projected to influence flooding in the watershed. Just really quickly, some other reasons why it's important to look at this. We've talked about flooding, but rain-on-snow events also do a lot of hydrological and geomorphological changes, especially in the Long Point region. It causes a lot of soil erosion, it can cause stream bank and stream bed changes, and it can also influence summer droughts later in the year. And then last but not least, of course, we have the water quality component. Because we're getting so much water running off, because we're getting so much erosion, we're going to get more nutrient loading into Big Creek that's ultimately going to end up in Lake Erie. And actually, last year, what I presented here was we know that the majority of nutrient loading in the Big Creek watershed happens just during a small portion of the year, about 15% of the year, when we see those really high flows. And these typically are present in February, March, and April, so that spring season when rain on snow is more likely to occur. Okay, so one other key component of my research that is tying this all together is the big bad C word, and that is climate change. So I'm interested in looking at how climate change is going to impact the frequency and intensity of rain on snow events, and how this in turn will affect these hazards. Okay, so today I'm going to present some results from two main questions that I had. The first is, does including the rain on snow process in our watershed model improve its ability to represent or characterize the Big Creek watershed? And then second of all, how will the impacts of climate change affect rain on snow events in Big Creek? So let's start with this first question. I haven't really brought up watershed models yet, so I'd just like to take a few minutes just to go over what a watershed model is and why we care. So just for a couple of minutes, just humor me with this. So a watershed model, simply put, is a computer's representation of a watershed and its key features using mathematical equations. So when we go out to Big Creek or Long Point and we look around, we see what's in this photo here. We see trees, we see the river flowing, we might see the sun out or rain falling. But when we translate it to something that our computer can see, it sees something like this diagram. And I know it's kind of hard to see, but in this diagram we have rainfall, we have evaporation, we have runoff. All of this is happening in the photo we see. This is just how the computer sees it. Okay, so what does the model do? It gives us simulated values for something in the watershed that we're interested in, using both mathematical equations that represent all those processes, as well as any monitored or observed data that we feed into it. And in my case, what we're interested in is modeling stream flow and eventually phosphorus. But today I'm going to focus on stream flow so we can track those high flow events. Why are we using these models? Why don't we just go out into the field and collect data? Inevitably, with any data collection program, we can't get absolutely 100% of everything. There's going to be time constraints, there's going to be money constraints, sometimes we can't even reach the site. So there's going to be missing gaps in our data and in our knowledge. So this is where models really come in handy, because they are able to fill in those gaps using the data that we already have that exists. And so once we have a model that represents our watershed, once we tweak those equations and once we feed in all of the data that we can use them to run experiments and scenarios that can help us understand the watershed's response to certain things like climate change or agricultural policy. And sometimes it would take years or lots of money to run these experiments in the field, so models help us with that. Okay, so when we look at what the model spits out, for my case, it looks like this. So here, this chart is showing stream flow. The black line is the observed data that we get from our monitoring stations, and the red line is what the model spits out based on those equations and all of the data, like weather data, evaporation data, all sorts of data that we feed it. What we want is we want the red line to match the black line as best as possible. And when it matches as closely as possible, then we know we have a model that represents the Big Creek watershed, and we can start to run those experiments. So going back to this question, essentially what I'm asking, or what I'm doing here, is saying we need to add an equation to the model in order to get it to represent those rain on snow processes. And the question is, does including this equation in our model help the model simulate stream flow? Does it get that red line closer to the black line? If it does, that means rain on snow is a really important process in this area. Okay, so this is kind of a more sciencey slide, but the gist of this slide is that Yes, including this rain on snow equation helps us better represent the Big Creek Watershed. How did we figure this out? We compared the model stream flow, that red line, to the observed stream flow to see if the rain on snow model, the one with the equation, performed better. We compared it with the stream flow from the model that didn't have that equation, and we found that that rain on snow model outperformed the model that didn't have it 76% of the time. So this really drives home that we should be including this process in our models when we're looking at this area, and that rain on snow is really fundamental here. And then if we look at what the data actually shows, what the model's actually spitting out, these are just some snapshots of spring stream flow. So from February to April in all of these different charts across a handful of years over the past decade, and all of these different graphs represent different places from Big Creek. And the main thing that I want to point out here is looking at the red line and the black line. The black line is the observed stream flow, and the red line is the stream flow from the rain on snow model. And then you might be able to see a blue line too. That's the model output from the model without rain on snow. And you can see that especially for those high peaks that we see in the black line where stream flow is really big, the red line is much better able to match those. So that's good news for us. We've improved our model. And now we are better able to represent the Big Creek Watershed, and we can start running those experiments and scenarios. For the sake of time, I'm going to skip over this slide, but I just wanted to point out that for the rain on snow model, it's also showing us that in terms of snow melt and the amount of water in the watershed, we're seeing much more earlier in the year, in February and March, rather than later in the year, like April or May. Okay, so now on to the climate change aspect. I'm going to be ending on this slide here, so there's only 2 figures left. So now what we want to do is see how climate change is going to impact these rain on snow events. To do this, instead of feeding our watershed model observed weather data, we now feed it projected weather data from a climate model. So basically, we're just giving it temperature and precipitation data that we would expect to see under a business as usual climate change scenario, and then we can see how the stream flow responds. So this figure is looking at a summary of stream flow from Big Creek per decade from 1980 on the left to 2100 on the right. You don't really need to understand this graph. All I want you to know is that the boxes kind of represent the average stream flow, and the dots represent those really extreme events. And although we don't really see a very strong signal, we do see a slight increase in stream flow over the next 80 years, and we do see a slight increase in those dots as well, those extreme events, other than the decade that we have observed data for, which shows a lot of dots. Okay, I'm going to end with this figure. This is the take-home figure that I think is really, really important. Here we're looking at the number of days where rain on snow events are occurring in February, March, and April from 2011 to 2100. The light gray bars show rain on snow events from 2011 to 2019. The blue bars show 2020 to 2059, and the red bars show up to 2100 from 2060. What we see when we look at the count of rain on snow days is that for February, they're pretty constant, but the drastic change we see is we're seeing more of these rain on snow events happening further on due to climate change in March. And there's actually a decline in these events in April as the century goes on. This suggests that temperatures are warming earlier in the year, and we're hitting that sweet spot earlier in the year. So rather than April, we're going to start to see more of these flooding events, more of these erosion events earlier in the year. What does this mean for us? It means there's going to be more flooding and erosion, like I just said, and so we really need to start looking at mitigation strategy and focusing that much earlier in the year rather than later. And that's the main figure I wanted to show you guys. Hopefully next year I'll have some more updates. And I'm just going to end on these key takeaways. So thank you for your time, and I welcome any questions.
Thanks so much, Sophia. So again, if you could come up if you have questions, please feel free.
I won't bite.
Yes, thank you. What kind of data for snowpack? Was that data being regularly collected by Environment Canada? And second of all, how would you, in your entire drainage basin, come up with different topography, different aspects, and now you'd have snowpack here, none here, et cetera, et cetera. So getting from that raw data, if you've got it, to an actual estimate.
Yeah, that's an excellent question. Snowpack data, I don't think is available. That's one of the things we get our model to simulate. And so what we do is there's a bunch of different parameters that we can tweak to represent the snowpack on the ground, including what temperature snow melts at, what temperature snow falls at, how much it accumulates over time, and then a bunch of solar radiation. Like there's a bunch of different parameters that calculate that snowpack on the ground. In terms of topography, the way we calculate the snowpack on the ground is not through the depth, but through the volume. So we call it a snow water equivalent, so it's a volume of water. And basically, for those rain on snow events, we say that if the snow water equivalent is above 1 centimeter or above 10 millimeters cubed, then there is an existing snowpack on the ground. But yeah, I do wish that we did have that snowpack data. That would make things a lot easier.
Any other questions? Perfect.
You got to jog up here.
Yeah, that was super well explained, considering how much probably behind the hood there's a lot going on. So my question is related to, and sort of this is maybe, when I think about temperature, for example, we see sort of like this average difference and we can kind of project that into the future, but there's also a difference in variance. So, sort of unpredictability. And so how does your model sort of account for increased variance, so in your climate change parameters, for example?
That's a great question. Unfortunately, that's out of my purview. That work belongs to another PhD student in our group, and it's also based on the climate model that we're actually using to output that data. That's part of the CMIP, or the Climate Model Initiative. So the model that I chose was based on another PhD's work that showed it was much better able to represent and project extreme events. So extreme precipitation events, extreme temperature events, which is exactly the kind of thing that we look at when we're looking at rain on snow events. So I tried to choose the best climate model as possible, but unfortunately I don't have a great answer in terms of the variance, but I hope that does it for you.
Any other questions? Paula, I thought you had your hand up.
Well, I was just going to say I don't have a question. We have a specialist here on snowpack.
Oh, excellent.
And he also, sorry, Paul.
Oh, hi, Paul.
Their mandate is to deal with blame. So I want to introduce Paul.
Hi, Paul. Yeah, for the viewers online, we're just being introduced to an expert in snowpack and snowmelt and flooding, so we'll have to have a conversation after. Okay, thank you, everyone.
Thank you. Okay, so next up is Alice Dabrowski, and Alice is from the University of Guelph from the School of Environmental Sciences. Alice is a first-year PhD student from U of G, again, School of Environmental Sciences. Her research is primarily focused on the ecology and pest management potential of immature flower flies, a group of bee and wasp mimicking flies. Her work spans across northeastern North America, but also includes collection sites throughout the Norfolk region. So thank you, Alice, for joining us.
Yes, so hello everyone. My name is Alice Dabrowski. I'm a first-year PhD student at the University of Guelph School of Environmental Sciences. Actually, technically like 2 months into my PhD, so very early on. And I work alongside Dr. Andrew Young and Dr. Jesse Pop. And I'm here to share some of our preliminary, emphasis preliminary, results for the 2022 and 2023 field season on flower flies in Norfolk County. Okay. So actually, who knows about flower flies here? Oh, more than I thought. Okay, they're also known as hoverflies as well, if you've heard that term used. And the adults, as you can probably tell from the pictures, are really, really good, at least some of them, are really, really good bee and fly mimics, and it makes them very interesting. They're primarily nectar feeders and well-documented pollinators of a variety of flowering plant families, and that includes, wild species as well as cultivated plants. And thankfully, they're fairly cosmopolitan. You can find them across most habitats around the world, excluding desert and Antarctica. And like other insects in our region, the adults are active from spring to fall. Now, the larvae are my study system and my golden goose for the PhD. And where is it? Like other brachyceran maggots, they have no head capsule and they have no legs. But what they do have is a pair of fused posterior breathing tubes. So these are like nodules at their tail end. Looks kind of like that. It can be modified. But it's how they breathe, and the fact that they're fused brings it to this family. They're also multimode feeders, meaning that they gain a lot of their nutritional requirements from different mediums, and this can be things like detritus, so they're being bacterial feeders, or they can be predatory, and that's actually where a lot of my PhD work is going to focus on the aphidophagus, or the aphid feeding larva. Now, unfortunately, they're not well researched. There are major gaps in terms of their description and the kinds of habitats that they're using, especially when you compare them to our European counterparts, where they're decades ahead of us in terms of documenting the diversity. And this can be attributed to the fact that they're difficult to collect. For the entomologists in the room, you'll be familiar with this, but for those who aren't, our typical passive collection methods includes things like malaise traps, which we've seen in other presentations, or pan traps. So these are systems that you can leave on site, and they collect different insects for you. Now the larvae, they don't migrate as much as adults do, so they're not often collected these ways. What I end up having to do is going out into the field, kind of anywhere I see fit, and if I see a plant with aphids on it, I have to collect the larvae by hand, one by one, and bring them into the lab. So very labor intensive, and this is how I spend my summer. Now, I'm sure some of you can piece this together, but they are of growing agricultural importance because of their pollination and pest control services. But even the non-predatory larvae still contribute to nutrient cycling in wild spaces. And because the fact, they're floral associates, they don't sting, they don't bite, they hover, which is where they get their other name. So they're really fun, they're really interesting, and I think that as the public kind of gets resources to help identify them, they can be the next charismatic insect model next to things like monarchs and ladybugs. Now, a bit about my PhD research. I'm looking to address these gaps through 3 different ways, primarily taxonomy, integrated pest and pollinator management, and community science. Now, the taxonomy, generally I'm going to be going out into the field, collecting as many specimens as I can, taking high-quality research-grade images of them, rearing them, and then using those images for descriptions. Those descriptions are going to end up contributing kind of at a lower level to community science initiatives and identification resources for the public. The IPPM side, so integrated pest and pollinator management, we're going to take a select group of these larvae. We're going to be placing them in laboratory experimental trials and looking at what their feeding rates are like at different temperatures. And this is with the hope that we can introduce them into unheated greenhouse settings, say up north somewhere where the operation isn't like massively scaled up, and hoping that they contribute to the pest control and the pollination of those spaces, and as well as creating some products that will be available for farmers and growers around Ontario. Actually, around North America, really, because these are native insects, and thankfully their range can be quite broad. And then the community science, we're going to try to develop strategies that people feel empowered, people feel comfortable taking flower flies and incorporating into their projects themselves. Now, when we look at flower flies in the Norfolk region, we're looking at physical specimens deposited primarily in two collections: the University of Guelph Insect Collection, which is the oldest insect collection in Canada, as well as the Canadian National Collection out in Ottawa. And between these two institutions, we see 7,500 physical specimens between them. And that's incorporating at least 166 confirmed species across 61 genera. So it's an impressive amount of diversity for a relatively small area, especially when you consider the fact that northeastern North America has approximately 416 syrphid species in total. Now, the iNaturalist data, the numbers aren't the exact same, but they're still representing a high amount of diversity in that square. So this is a square I'd mentioned earlier. Again, 79 species, almost 1,000 observations. And that means that we're still getting good diversity being represented on these online platforms, and that people are curious, which is fantastic. They're curious, they're taking pictures, and they have a platform where they can share that with other people. And thankfully, iNat also takes into consideration some of the data that's important for entomological work, namely the coordinates and the date that things have been observed. Now, oh boy, this number. So using kind of the same area and all of the data on iNat, we only see 6 observations in total of the larval stages, which is really sad. I mean, that's why I'm here, but it's still really sad. Going back to the institutional collections, they have a big fat 0, nada, nothing. So that's even worse. And this is important to note because it's not that these adults just spontaneously pop up. You know, they had to have an earlier life stage. So we should realistically be seeing the same amount of diversity in that square in the larval stages, but unfortunately, again, we don't know what habitats they're using or what they even look like. Now, in terms of my research for 2022 and 2023, I've been collecting from primarily 2 sites in the Norfolk County. We have Manister Track, which has been mentioned before, operated by St. William's Conservation Reserve, and we have Turkey Point Provincial Park, obviously collected under the appropriate permits. So we're very thankful for their support. And the habitats are fairly opposite in that one is an open canopy, fairly dry, and the other is closed canopy and much more wet. And although we're still looking to ID things to species, we have 111 specimens total. So, you know, it could be more, but still identifying it. Some of the notable adult findings that we have center the 2 species on the left. We have Tripidia albostylum and Pterolastes thoracicus, which are primarily southern species. We don't have any publication or confirmation that they occurred in Canada. And the story goes, in 2022, as part of the Young Lab, I visit the Manister Tract, and I collect a specimen, as I do. And a few months later, because, you know, IDing often gets put on the back burner, but a few months later, I identify it as Tripidia albostylum, this guy right here. And it's incredible because even within their typical range, they are considered to be fairly rare. So this is really exciting, especially as someone who's just starting their PhD. Yay. A paper, yeah. So while I'm working on the paper, I wanted to confirm that it wasn't just a vagrant, it wasn't just something that accidentally blew in here. So I start looking at their biology. And they are the maggots, or the larval form, because we don't like using the word maggot. But the larval form is an aquatic life stage. So we suspected that if we go from the collection point to any of the nearby wet areas, we'll be able to potentially find a stronger population representation. So that's what we did. We went back to the site, and a colleague of mine, actually, Brendan Gallant, found Pterolastes thoracicus, which is, again, something that's has not been collected in Canada before, and another paper. So we submit all of the material that we have for the Tripidia to the Journal of the Entomological Society of Ontario, and we speculate that this represents a range expansion for at least this species, as well that, we didn't have any luck at the wet areas, but there's still potential that they could be there, so additional work had to be done. And the story would be nice and clean if it ended there, but it doesn't. Like any other naturalist, I really wanted to take advantage of the last few good collecting days of the summer. So on October 1st, I went out again, and this time we found both Tripidia albostylum and Pterolastes thoracicus on the same day, within a few hours of each other, which is, mind-blowing. I told my professor, and over the phone, I actually called him, and I was like, oh my God, we got this cool stuff, and he's like, man, I wish I went out, because he's yet to collect either of these. Yeah, you can hear him getting heckled. But yeah, very exciting. And the thing is, while this is a great point of additional information, it does change our assumptions on at least Tripidia albostylum, because, first of all, they're not at these wet sites like we were thinking. They might be, but we haven't been finding them there. We're finding them at the very, very dry sites, which is, if you look at INAT records, really odd. They're typically found in proximity to water. So something is going on there that's bringing them to that spot. And then secondly, the larvae as bacterial feeders, we don't expect them, or we don't assume that they're resource limited. So the adults, when they eventually become adults, they should be generally uniform in size. And I don't know if it's obvious to you, but in person, the difference between the sizes is a lot more pronounced. So something's going on there that's contributing to this size difference, and additional work still has to be done. But yeah, the assumptions that we're making clearly are not holding up for very specific things. And then similar thing, the larval findings, again, still need to do some ID, but Norfolk County was one of the first places where I started looking at other forms of plant damage. Initially, when I was looking at larvae, we'd have to make visual confirmation that there's some type of aphid colony, so that often looks like a young shoot of a plant of some kind, and then you have these things. You have these aphids that are crawling over each other, and they create these dense colonies, which is great, because oftentimes you do find larvae there. But we started expanding out to things like leaf curls or sumac galls. And these things are occurring at different times of the year, so it meant that we had to keep going back to these sites, keep our eyes open for the potential plant damage and what it would look like at that time of year. And what we ended up finding were different flower fly species, which, reasonable assumption. But not only that, we're able to expand from our initial subfamily, which is the Surfinae, and expand towards Pipizinae, where before my work, there are very few good pictures at all anywhere of these larvae. And right there, in that little cuddle puddle, there's 15 of them. So a lot of material for imaging. And all of this goes to show that larval work, you have to be at the right place at the right time. And that means you have to be out in the field regularly and doing a lot more exploratory work. Don't just focus on one familiar type of approach. You have to expand where possible. Now, this goes without saying, but Norfolk County does support a high diversity of flower fly species in the area, again, over 100. And like I'd mentioned, syrphid larva habitat assessments require consistent monitoring. And then community science is important for trap evasive insects. As we've seen with the INAT observations, it's people going out and reporting things because they're curious that are increasing the number of records we have for the area. Now, future work is we're going to maintain our relationship with the provincial park system, and we're looking to expand to additional sites with the Nature Conservancy of Canada in Norfolk County, but thankfully, you can do this work anywhere. So if anyone's interested, I'm around quite often, and if you want to tag along, feel free. If you're curious, we do have some resources available in partnership with Pollination Guelph. We have a webinar that was recorded earlier this year. It's at that YouTube. I can share it with anyone who's interested. But it's at this YouTube link, and it goes into a basic introduction to flower fly identification and includes some overview of the larval stages. And then we also have a preliminary field guide to the flower flies of Wellington County, and obviously including larval pictures for the first time where possible. And that'll be coming out, I think, at the end of November. So I'd like to thank all our partners that make this work happen, and obviously available for questions and things. We're early for lunch, too, so that's nice.
Does anyone have any questions?
Or if you want to just come up and say how much you love flower flies now, that's cool, too. They are amazing. Sorry? Yeah. Oh, let me point it out. I'm not just staring at my hand. There's a flower fly there. Oh, thank you.
Perfect. Well, if there's no other questions, we might be a little early for lunch, but I encourage you to do a little bit of networking until the food shows up. So let's give another big round of applause for all of our speakers.